Hey, this is section 9.4 of Algebra 2. We're continuing to build on our coterminal angles. If you remember, look on page 429 at the top, they show a picture of a 120-degree angle. They've rotated it through and they've put in their 60-degree triangle. Now, if we think about this as we've gone 120 degrees, just like they have here, and we've drawn down to the x-axis, it was a 60-degree angle. All right, we've learned something about 60-degree angles because we're creating right triangles, and if this is 60, this has to be 30. So I can put my values in. The side opposite the 30-degree angle is the short leg, that's my 1. The hypotenuse here is always 2. And if I go across from the 60 degree, I'm going to have the square root of 3. But we have a problem. We are in the second quadrant here, and x going left is a negative value. Now y is still positive, and we said that r is always positive. But this is going to change the value of my sine, cosine, and tangent, okay? So if I were to find the sine of my 60-degree angle, sine is opposite over the hypotenuse, square root of 3 over 2. That's good. That's just like it would have been sitting in the first quadrant. But if I look at the cosine, I should have rho in here as well. Cosine of rho, then cosine is going to be negative 1 over 2. In this quadrant, it was a positive 1/2. Okay, so we're going to find that it's going to change depending on the quadrant. Now, we don't always want to have to draw those in there to figure it out. So we have a mnemonic to help us, okay? All students take calculus. Now, at the time somebody came up with that, it was true. You were required to take calculus, and I've misspelled it. Now, not so much. Many of you will not take calculus, but it's still something easy to remember that we can work with. So A, S, T, C. Now, these letters should look fairly familiar. Now, A is simply going to stand for all. S should remind us of the sine function, T of the tangent function, and C of the cosine function. Now these are going to work with the quadrants. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In quadrant 1, all of the functions, sine, cosine, and tangent, are always positive. Okay, we saw that earlier. Now over here we saw that which one was negative. All right, so let's think about it. This tells me in the second quadrant that the sine is going to be positive. That means that tangent and cosine will both be negative, and that makes sense because the cosine will be the adjacent over the hypotenuse, so we're involving that negative, and the tangent will be opposite over adjacent, so again we're involving the negative. Third quadrant, T tangent is positive, so that means that sine and cosine are both negative. And in the fourth quadrant, we see that the cosine is positive, which means that tangent and sine are both negative. All right, so learn, all students take calculus, and that tells us which trigonometric functions are positive in each quadrant. All right, that needs to be memorized. You'll have a section of homework that will just work on that particular idea. Now, if you look down at example 9.4a, you will see that we are given tangent of theta is greater than 0 and cosine of theta is less than 0. Okay, and we want to find where we would draw that triangle, and it's very specific. Again, let's look at all students take calculus, and we're going to do that once for each. ASTC and ASTC. TC. Now, if the tangent is greater than 0, that means it is positive. Tangent is positive where all of them are positive and where tangent is positive. Cosine is less than 0. That means the cosine is a negative value. Okay, so cosine is negative in these two because here all of them are positive, here the cosine is positive. Now, if I want both of these to be true at the same time, that's only going to happen in the third quadrant. So later we would see, if we were actually going to work with this, that our triangle would be over here in the third quadrant. Okay, in part B, we have that sine of theta is greater than 0 and that the cosine of theta is less than 0. Again, ASTC, ASTC. If the sine is greater than 0, that means that it is a positive value. So when all are positive, the sign is positive. And when the sign is positive, the sign is positive. Here the cosine is a negative value. Here all are positive. Here the sign is positive. So the cosine has to be negative. Here the tangent is positive, so the cosine has to be negative. And here the cosine is positive. So if I compare these and both have to be true, the only place they can both be true is in the second quadrant. So if I were graphing and working with this one, my triangle would be drawn in the second quadrant. Notice that they're drawn in the quadrant and then they always go toward the x-axis. All right. Now, in example 9.4b, it takes us one step further. Okay. So remember, if it gets to be a little bit too much, pause, give it some thought, work some practice problems, and then start the video back up. That's the beauty of doing it on video. I know there's lots of disadvantages, but we also have an advantage in that you can watch it as many times as you need to. Now in 9.4b, it tells us that the sine of theta is equal to 1 over the square root of 2. Now this is not in a good reduced form, but it's important that they put it this way because it gives us the opposite and the hypotenuse. If they had reduced it appropriately, we would not have a clear idea of the value of the opposite and of the hypotenuse value. And we know that the cosine is less than 0. All right. We know that the sine is a positive value, so all students take calculus, and we know that the cosine is negative. Now we've seen several times that when the cosine is negative, we're in the middle too. The sine is positive here and here, so sine they share. So that's why we were putting it here. Now, because of the values they gave us, the opposite to my row, the opposite side, is going to be equal to 1, and the hypotenuse is the square root of 2. Now, you may recognize that if the hypotenuse is the square root of 2 and one of the legs is 1, that forces the other one to be 1. It's a 45, 45, 90 triangle. If you don't recognize it, work the Pythagorean theorem to find it. But again, because we're in the second quadrant, x is negative, so I have to remember to put that in. And then what the question asks is to find the other two trig functions. So I know the sine of theta is 1 over the square root of 2, which must be now at this point rationalized. Okay, and then the cosine here is going to be negative 1 over the square root of 2, or negative square root of 2 over 2, and then we will find that the tangent will be equal to opposite over adjacent 1 over negative 1, which simply reduces to negative 1. So first I have to figure out which quadrant I'm in. We have to draw the terminal side, connect to the x-axis, put in the values that were given, and calculate the third one using the Pythagorean theorem, and then go from there. So you're going to have one whole section that just asks you to figure out which quadrant it's in. And then you're going to have a second section that gives you information like so. So you still have to determine the quadrant, draw a sketch, put in the two values you know, find the third value, and then find sine, cosine, and tangent. Okay, I'll talk to you later.